Okay, if you've been following along with us in sequence, then we're just slightly under halfway there. This is sub-element T4, amateur radio practices, and there are two sections to that. There's going to be an A and a B, the station setup, and then T4B is operating controls. As a reminder, this is the exact questions and answers with explanations, the exact questions and answers as they will be seen on the test. And we will read the question and the correct answer along with the explanation and just sort of ignore the wrong answers. In those questions that have on all of the above or both A and B or both B and C, something like that, the explanation usually covers the correct answers that were in the sequence other than just the choice that said all the above. So section T4A will be station setup, connecting a microphone, power source, and computer, RF power meter and SWR meter placement, digital equipment and computer interfaces, bonding and mobile radio installation, and battery calculations and electronic keyers. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? And the answer is D, 13.8 volts or 12 amps. Of course, amps is spelled out amphrase, I believe is how it's pronounced, but I will refer to that word as amps for short due to my hillbilly inability of pronouncing French words. So why is this the answer? Mobile FM transceivers run on 13.8 volts. That's the standard vehicle charging volts for 12-volt lead acid systems. Ruling out 24-volt options, a 50-watt transmitter is only about 30 to 40% efficient, needing roughly 143 watts of DC input. At 13.8 volts, that requires about 12 amps. So there's a formula there, 13.8 volts times 12 amps equals 165.6 watts, which covers the transmitter's inefficiency and other losses. A 4-amp power supply would only provide 55 watts and not nearly enough. Which of the following should be considered when selecting an accessory SWR meter? A, the frequency and power level at which the measurement will be made. An SWR meter measures standing wave ratio, indicating how well impedances are matched in your antenna system. The two critical factors for choosing an SWR meter are its frequency range and power handling capability. Using a meter outside its frequency range gives incorrect readings, and exceeding its power rating can damage the meter. Distance from the antenna and anticipated SWR levels aren't selection criteria. Why are short, heavy gauge wires used for a transceiver's DC power connection? A, to minimize voltage drop when transmitting. When transmitting, a 50-watt mobile radio draws 10 to 12 amps. Longer or thinner wires have more resistance, which cause voltage drop. If voltage drops too low, the radio may malfunction, reduce power output, or shut down. Short, heavy gauge, or thick wires minimize resistance and therefore minimize voltage drop, ensuring the transceiver receives adequate voltage during high current transmit periods. How are the transceiver audio input and output connected in a station configured to operate using FT8? A, to the audio input and output of a computer running FT8 software. FT8 is a popular digital mode where the computer generates and decodes signals through audio tones. The transceiver's audio output receives signals goes to the computer's audio input, so the software can decode signals. The computer's audio output, generated tones, goes to the transceiver's audio input for transmission. The computer runs FT8 software such as WSJTX that handles all the encoding and decoding. Where should an RF power meter be installed? A, in the feed line, between the transmitter and the antenna. An RF power meter measures the radio frequency power flowing through the transmission line. It must be placed at the feed line between the transmitter and the antenna to accurately measure forward and reflected power. Placing it at the power supply would only measure DC power, not RF, and at the antenna feed point would be impractical, and between the mic and the transmitter wouldn't measure RF output at all. What signals are used in a computer radio interface for digital mode operation? A. Receive audio, transmit audio, and transmitter keying. A computer radio interface for digital modes carries three essential signals: receive audio from radio to computer for decoding, transmit audio from computer to radio for encoding, and transmitter keying, PTT or push-to-talk control, to switch the radio between receive and transmit. These three signals allow a computer to fully control digital mode operation. Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? A. Computer line in to transceiver speaker connector. For all digital modes, received audio must flow from the radio to the computer for decoding. The transceiver speaker output carries receive audio, and the computer's line in or audio input receives it. This connection lets the computer software hear what the radio is receiving. The transmit path would be computer line out to the radio's microphone input, but this question specifically asks about the receive connection. Which of the following conductors is preferred for bonding at RF? A. Flat copper strap. At radio frequencies, current flows primarily on the surface of a conductor, skin effect. Flat copper strap has much more surface area per unit of cross-section than round wire, making it a better RF conductor. Its low inductance also helps bonding, connects equipment, chassis, and grounds together to prevent RF voltage differences, and a flat strap does this most effectively at RF frequencies. How can you determine the length of time that equipment can be powered from a battery? A. Divide the battery ampere hour rating by the average current draw of the equipment. Battery capacity is rated at amp hours, AH. If a battery is rated at 20 amp hours and your equipment draws an average of 2 amps, you divide 20 amps hours by 2 amps, equals 10 hours of operation. This is a straightforward unit analysis. Amp hours divided by amps gives you hours. This is essential for field operations, emergency preparedness, and portable station planning. What function is performed with the transceiver and a digital mode hotspot? A. Communication using digital voice or data systems via the internet. A digital mode hotspot is a low-power device that connects your digital capable transceiver, DMR, D-Star, System Fusion, etc., to the internet, allowing you to communicate with other operators worldwide through a digital voice data network. It essentially acts as your personal micro repeater, linking your radio to the internet-connected digital voice servers and reflectors. Where should a negative power return of a mobile transceiver be connected in a vehicle? A. At the 12-volt battery chassis ground. The negative or ground wire of a mobile transceiver should connect directly to the vehicle's battery chassis ground, the negative terminal of the battery or the chassis ground point at the battery. This provides the shortest, most reliable ground path with minimal resistance. Connecting to random vehicle body points can introduce noise, voltage drop, and unreliable connections. What is an electronic keyer? A device that assists in manual sending of Morse code. An electronic keyer assists operators in sending Morse code manually by generating properly timed dots and dashes. When you squeeze a paddle, the keyer produces the correct timing for DIT-DA sequences. This is different from a memory keyer, which plays back stored messages, or a decoder. The electronic keyer helps you send cleaner, more consistent CW by handling the precise timing while you control the content. And our key takeaways. Power supply, 50-watt mobile radio needs 13.8 volts at 12 amps, and that matches the vehicle's electrical system. SWR meter selection, choose based on frequency range and power level. DC wiring, short, heavy gauge wires minimize voltage drop during transmit. Digital modes, computer audio in and out connects to radio audio out and in. PTT signal keys the transmitter. RF power meter, install in the feed line between the transmitter and the antenna. Bonding, use flat copper strap at RF. More surface area due to skin effect. Battery life, amp hours divided by average current draw equals hours of operation. And mobile ground, connect negative return to battery chassis ground.